guys, here you can see that one more video has been came on the Array DSA part. So here you can see it. So in today's video, I'm telling you about the Array DSA part. And in today's video, this is a topic of my video. Okay, but this is Array part we are covering in today's video. So please like this video, share your friends, subscribe to my channel, and don't forget to all the notification bell also. So you know about these type of videos on this channel. So now let's move toward on the big screen and let's do a coding with laughing. So let's talk about what is the majority element. Given an array means ARR, find the majority element in the array. If no majority exists, it's written -1. A majority element in an array is an element that appears strictly more than ARR dot size /2 times in the array. Okay, and there is 450. Okay, and then 520. Okay, perfect. Now examples. If I give you the example, this one input means ARR square brackets, then in the curly bracket 1 1 2 1 3 5 1, and the output will become 1. Why? Because there are note that the 1 appear 4 times, which is more than 7/2 times. So that's why there is coming 1 output. So if you give the input ARR, then 3 3 4 2 4 4 2 4. So it gives you the output -1. There is no element whose frequency is greater than the half of the size, okay, of the array size. Now 3, the output will become 3 because appears explanation appears more than n/2 times. Try it on GFG practice. Table of content. First, native approach. Using two nested loops means 0 and 2 and time and 0 1 space. Number 2, better approach using sorting /0 log n and time O1 space. That optimal approach means using hashing /0 and time and 0 and space. Then expected approach using Morse voting algorithm 0 and time and 0 1 space. Naive approach then using two nested loops 0 and 2 and time 0 1 space. The idea is to count the frequency of each element using nested loops. The first loop iterates through each element of the array, treating it as the majority element. For each element, the second loop counts its occurrences in the entire array. After the second loop, we check if this element appears more than n/2 times, where n is the size of the array. If it does, it is the majority element in the array. Below is the one implementation of the above approach. Here you can see it, one implementation of the above approach in the C++ program. Here we find the majority element. So let's run this example. So the output will become while. Let me tell you. First of all, let me run this in my Google in the Rapplet. Like you know, in my Rapplet series, I'm using the in my DSA series of array, we are using the Rapplet. Okay, so let me open my Rapplet file, and here I am pasting my code. So there is coming the number. So let's remove this number. There are for the 38 numbers. So let's remove this using the AI assistant. Okay, so where is the AI assistant? Where? Okay, there it is. So I am saying remove numbers. Okay, I am saying remove numbers 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 10 30 31 32 33 34 35 36 37 38. Okay, now let's start. So it will be remove my all the numbers which I have said it. So now it is starting to remove it. So it has been removed. So I am clicking on the copy and then I am pasting it here. So when I run it, so now it is giving me the outputs will be 1. Let me show you. So it take a little bit time. So it will give me the output 1. Now why? Because the array in our array, the one is many times, like 1 or 4 times. Okay, so that's why it is printing me 1. So if I write it 2 and 2, so it give me the output 2. Why? Because I write 2 4 times. Let me show you. Here you can see it will give me the output 2. Now time complexity 0 and /2, then auxiliary space 0 1. Better approach using sorting /o and log n and time and 0 1 space. The idea is sort the array so that similar elements are next to each other. Once sorted, go through the array and keep track of new or keep track of how many times each element appears. So when you encounter a new element, check if the count of previous element was more than half the total number of elements in the array. If it was, that element is the majority and should be returned. If no element meets this requirement, so majority element exits. Now below is the one implementation about above approach. Here you can see it. So let's run this above approach. So there are 42 codes. Okay, 42 codes. So the output will become 1, and let's see it. So let me say remove numbers 1 2 3, and I'm writing 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 and 30 31 32 33 34 35 36 37 38 39 40 and 41 and then 42. Okay, so I write it. So when I enter press, it will be started removing all the numbers. So let's wait and watch. Okay, so now it has been started to remove it. So when it has been removed, so I'm clicking on the copy and then I'm pasting it a paste. So when I run it, so it give me the output. Let's see the output of it now. It is giving me the output 1 because I write 1 many times. There is 1 1, then here I write 1 and I write 1 4 times. So that's why the 1 has been coming in my output. Here we use the time complexity O n log n and luxury space 0 1. Optimal approach using hashing slash O n time and O n space. Okay. The idea is to use a hash map to count the occurrences of each element in the array. First, traverse the array once, and for each element, okay, update its counts in the hash map. Then after updating the count, check if count exceeds in n/2. Then if such an element is found, return it immediately. If no elements count exceeds n/2, return -1. Below is one implementation of the above approach. So let's run this example. So let's come on it here, copy it and then paste it. And there is a 33 code. Okay, so let's say to remove this 30, remove numbers 1 till 33. So now it is started to remove it. So when it has been removed, so let's copy it and then paste it. So let's see the output of it. So now it is giving me the output. So now it give me the output 1. So why I said give me the output 1, because I write 1 4 times and it give you the same output. But in this example I use the different method. We use the time complexity ON, okay, and luxury space ON. Expected approach using more voting algorithm like 0 1 time and 0 1 space. This is a two-step process. The first step gives the element that may be majority element in the array. If there is a majority element in an array, then this step will definitely return majority element. Otherwise, it will return candidate of majority element. Number 2, check if the element obtained from the above step is the majority element. This step is necessary as there might be no majority element. Follow the steps below to solve the given problem. First, initialize a candidate variable and count a variable. Number 2, traverse the array once, means first, if the count is 0, set the candidate to the current element and set count to 1. Number 2, if the current element equals the candidate, increment count. Number 3, if the current element differs from the candidate, decrement count. Traverse the array again to count the occurrences of the candidate. If the candidate's count is greater than n/2, return the candidate as a majority element. Below is an implementation of above approach. So let's run this example. So there is a 46 code. So let's remove it. So it give me the output 1. Let me show you. So let me come on my assistant and let me say remove numbers 1 till 46, because there is a numbers 1 till 46, so I say 1 till 46. So it is started to remove it. So let's wait and watch. So here you can see it. When it has been removed it, so I'm click on the copy and then I'm pasting it here. And then I'm running. When I run it, so now it take a little bit time that it will be removed. So now it take a little bit time. Okay, so it gave me a 1. Why? Because there is 1 many times, and like I've told you, in this we use a different method. We use a time complexity O1 and alloxary space 01. Okay. Now our this chapter has been ended by the name of majority element. So majority element. Okay. So now let me meet you in the next class and next very amazing class, and let me give the out of this video in the big screen. So let's move to on the big screen, and let me tell you how is my performance is going and how is my all the thing is going and which new course I will be started on this channel. Tell me in the comment section below, and in the comment section below tell me how's my editing, how's my thumbnail, how's my title, and please share my videos with your friends, family members, neighbors and cousins and all of that. Okay, so now let me give the out of this video in the big screen. So let's move toward onto the big screen and let's give the outro of this video. And that's wrap, folks. Congratulations, you have made it through. By now, you are basically an array whispers array. Don't confuse you anymore. They fear you. If you enjoyed this session and learned something new, don't forget to like, share and subscribe, because sharing knowledge is cooler than debugging at 3 a.m. Got any questions or want to suggest a topic? Drop it in the comments and I will dive in a faster than a loop iterating through an array. Until next time, keep coding, keep laughing, and remember, if your array gets out of bounds, just call it a feature. Okay, so bye bye and happy coding.